Hello guys, and welcome back to another video on important questions of chemistry. So now we are talking about haloalkanes and haloarenes. Hi, so let's get started. First is Finkelstein reactions. Alkyl halide plus sodium iodide in the presence of triacetone to give alkyl iodide and sodium halide. Here X means chlorine and bromine. Fluorine is not involved here. Chloroalkane or bromoalkane on heating with sodium iodide in triacetone gives alkyl iodide. Just remember key points over here. Finkelstein, sodium iodide, triacetone, sodium iodide, triacetone, sodium iodide, triacetone. And all these examples you can write. So next is Schwarz reaction, alkyl. So these both are like sisters and brothers. It is alkyl halide, it is also alkyl halide. It is sodium iodide, but it is metal fluoride, which is silver fluoride. See, metallic fluoride. It might be mercurous fluoride, cobalt, or antimony to give alkyl fluoride. Okay. Alkyl halide on heating. Alkyl halide on heating with metallic fluoride like AgF, Ag2F, COF2, SpF3 gives alkyl fluoride. Example: ethyl bromide in presence of silver fluoride gives ethyl fluoride and silver bromide. Next is SN2 reaction. Again, it is also SN1 reaction. A really important question. They might ask the mechanism. So it stands for unimolecular nucleophilic substitution reaction, and it is generally carried out in polar protic solvents. Okay. So next is tertiary alkyl halides undergo SN1 reaction. SN1 reaction follows first order kinetics. Tertiary alkyl bromide on hydrolysis with aqueous sodium hydroxide. Aqueous sodium hydroxide gives tertiary butyl alcohol. So this is tertiary alkyl bromide. As you can see, tertiary alkyl bromide on hydrolysis with aqueous sodium hydroxide gives tertiary butyl alcohol plus sodium bromide. The mechanism: SN1 SN1 involves two steps, and SN2, see here, SN2 involves only one step. SN1 involves two steps. Okay, the first is slow step and the next is faster. As we know, slow steps are rate determining steps. The same way, first step is rate determining step. Tertiary butyl bromide ionizes slowly to give sp2 hybridized planar tertiary butyl carbocation and bromide ion. So this slowly gets ionized to tertiary butyl bromide. Ionized slowly to tertiary butyl carbocation. As you can see, carbocation. Okay, that's the reason. And it is sp2. It is planar. sp2 and planar to give some ion. In the next step, a nucleophile OH minus from aqueous NaOH attacks planar carbocation on either side and gives tertiary butyl alcohol. Okay. This thing over here, a nucleophile OH minus from aqueous NaOH attacks this carbocation on either side to give tertiary butyl alcohol. Okay, so what we took is that we took a bromine in the place of alcohol here. Okay, and the final thing is that just alcohol jod do. That's it. SN1 reaction results in the formation of racemic mixture. Order of reactivity is tertiary more than secondary more than primary alkyl iodide, and the rate is R into Rx. This is important, guys. Remember, it is a nuclear substitution reaction. First order kinetics. NaOH aqueous NaOH में ऐसा आएगा तो टू स्टेप्स. फर्स्ट स्टेप स्लो स्टेप होगा, आयोनाइज करके कार्बोकैटायन बनाएगा tertiary butyl carbocation. Okay, 1 2 3 4, so butyl. The next is fast step. A nucleophile OH minus attacks on the both side, so to get you will get tertiary butyl alcohol. And the next thing we're talking about SN2 reaction. SN2 reaction, it stands for binuclear nucleophilic substitution reaction, and it all follows second order kinetics. Again here also sodium hydroxide. And the next is mechanism. Chloromethyl chloride in the presence of sodium hydroxide is methanol. It involves only one step. It involves only one step. So the nucleophile OH minus attacks electron deficient, which means it is in need of electron obviously carbocations electron deficient man from the rear side or the back side of the carbon atom to form a transition state which is unstable. In transition state, a partial COH bond is formed and a partial CCl bond is broken. This is broken and this is formed. The product CH3OH, that is methanol, obtained has inversion configuration. Methyl chloride. Okay, this is a carbocation, as you can see. This is minus, this is this, and it will attack here. There is a breaking of CCl and making of OH bond, and you will get methyl alcohol chloride ion. Order of reaction is opposite of SN1. Here it is CH3X first, and then primary, and then secondary, and then tertiary. Rate is K into Rx, nucleophile OH minus K into Rx. So next is talking about racemic mixture and racemic modification. Racemic mixture is equimolar mixture of levorotatory and dextrorotatory isomers. Racemic modification is a mixture containing two enantiomers in equal proportion will have zero optical rotation. Okay, a mixture having two enantiomers in equal proportion will give zero optical rotation. It is racemic modification. Next is racemic mixtures are optically inactive. Why are they optically inactive? Because the optical activity of D isomer gets cancelled by that of the L isomer. The optical activity of D isomer gets cancelled by that of L isomer and not L isomer by D isomer. Okay. Next is chiral carbon. Oh shit. Yeah. Next is about chiral carbon. A carbon bonded to 4 different atoms or groups is chiral carbon. As you can see, bromine, OH, CH3 all are different. Chirality. The objects which are non-superimposable on their mirror images, the molecule should contain asymmetric carbon atom. Next are enantiomers. Enantiomers are optically active isomers which are non-superimposable on their mirror images. Optically active isomers which are non-superimposable on their mirror images. 2-bromobutane. Next are diastereomers. Not the mirror images of each other, differ in 3D connectivity. Okay, look here, it is syn, then it is trans, like that. Next is racemization, the process of conversion of enantiomers to racemic mixture. Next is Zaitsev or Zaitsev, both the same. Zaitsev's rule, it states that during dehydrohalogenation of reaction, the preferred product is that alkane which has greater number of alkyl groups attached to the doubly bonded. So basically here dehydrohalogenation means the bromine or the whatever the halogen is present is being removed, and the double bond is formed where the greater number of alkyl group is present. Okay, look here and look at the difference. Okay, where are the more number of alkyl groups are present? Here only one, the terminating one, but here it is like this. You will add here, and this is the major product. Next is what is Grignard reagent is organomagnesium halides, ethyl magnesium bromide, all those, and then Wood's reaction, alkyl halide on heating with metallic sodium in dry ether gives higher alkane, Rx plus 2Na presence of triether gives R higher alkane. Just add another alkane present in the reaction. Next is alkyl halides are less reactive towards aryl halides are less reactive towards the nucleophilic substitution reactions. The reasons are due to resonance effects, it becomes stable. Difference of hybridization of carbon in CX bond due to instability of phenyl cation. Next is Friedel-Crafts alkylation. The alkylation and acylation reactions of haloarenes or with RX or acyl halide in the presence of a catalyst like anhydrous aluminum chloride. First is Friedel-Crafts alkylation, next acylation. Chlorobenzene reacts with RCl in the presence of anhydrous aluminum chloride to form orthomethyl chlorobenzene and paramethyl. So there are two products out of which ortho takes the position of a major product. So chlorobenzene reacts with alkyl chloride. Here it is methyl chloride in the presence of anhydrous aluminum chloride to give ortho and para. And it's here. Next is Friedel-Crafts acylation. Chlorobenzene reacts with acetyl chloride in the presence of both the catalyst in these two reactions. Friedel-Crafts is anhydrous aluminum chloride. Just here it is RX, here it is acetyl chloride. Again to give ortho and para. Okay. Anhydrous aluminum chloride, anhydrous CH3Cl, CH3OCl. Okay. Now you just add here. Next is Wood's fitting reaction. Aryl halide reacts with an aryl halide reacts with an alkyl halide in the presence of sodium metal in dry ether gives alkyl arene. Example bromine halide, which is bromomethane, reacts with this in the presence of sodium metal and dry ether to give toluene with bromine. And so it is important, guys. Wood's fitting is also important. Next is fatigue reaction. Two molecules of aryl halides react with sodium metal in the presence of dry ether gives toluene. There are two molecules, sodium metal, dry ether. Just attach them. Okay, simple. Next, what is phosgene, Baba? Phosgene is highly poisonous gas, which is carbonyl chloride. Freons, the chlorofluorocarbon compound of ethane and methane. Bromoalkane have high boiling point than chloroalkane because bromine is a larger and heavier atom, resulting in stronger intermolecular forces, that is van der Waals forces, more energy to overcome. Next is ambidentate nucleophile are the nucleophiles that have two or more nucleophilic sites, and that is they donate a pair of electrons from two different atoms. RX plus cyanide, R cyanide, alkyl cyanide, and when it is K, cyanide, RNC, isocyanide. Yeah, that's it, guys, and thank you so much for watching the video. And if you like the video, then hit the like button, subscribe, and share to your friends. That's it. Bye.